Hey guys, this video is talking about section 2.5 using linear models. And so this entire chapter, we have been looking at equations, specifically slope-intercept form, point slope form, and standard form. But in all of our situations so far, every single point or ordered pair that we've had has been on the line. And so if you have your line, the point has been here, 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 like they've been all on your line. However, real world data does not do that. You have messy data that doesn't line up exactly on a single line. However, there are patterns and correlations where those ordered pairs are going to link up and kind of go in the same direction. You're going to have a correlation or a pattern with your data. And so in order to kind of use that information, then we want to create that pattern, and that pattern is going to be our regression line. And so today's lesson, we're going to be talking about scatter plots and regression lines and how to find them. So with your calculator, you're going to be using your calculator to find regression lines. So make sure that you have a TI-84 calculator right next to you as you are working. Also, make sure that you have your notes with you as well. So make sure you have those two things and you will be golden. All right. So let's go ahead and get started with the notes. By the end of this lesson, you will be able to take the real world data and situations and model it with a linear equation. And then we're going to use that equation to draw conclusions about the situation. So first off, let's get our first vocab word. A scatter plot. A scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. And as we know, we have ordered pairs X, Y. And so the two sets of data that it's talking about, you're going to have an X value, which is your domain. And this will be the independent variable. It acts on its own. And you'll also have your Y value. That's an and symbol, by the way. You'll also have your Y value, which is your range values. And this is the dependent variable. Y depends on X for whatever situation. All right, so we'll get through some examples and you'll see that as we go. But you can use a scatter plot to determine the strength of the relationship or correlation between the data sets. So sometimes your data matches up really well together and you can see that there's a pattern, but sometimes there is no pattern. For example, if you are looking at someone's height and I totally blanked on what example I was going to give, but let's give a non-correlation example right now. So non-correlation would be if you're looking at someone's height and how many movies that they watch. Well, maybe someone who's really tall likes movies a lot, and someone who's shorter, like a kid, likes Disney movies. So there's not a correlation there. However, if you had like, oh, your height and like your shoe size, because as you grow taller, your feet are probably going to get taller or longer too. And so there's a correlation there, but we will be able to see more as well. But interestingly, when you have a relationship, when you have correlation, that shows through on your scatter plot. So the closer the data points fall along the line, the stronger the relationship between these two sets of data. And then also too, as your points get closer together, it means that you have the stronger relationship, but we can call it as like a positive or negative correlation. All right, so as our data gets more related together, the points are closer together, you're going to either have a strong positive or a strong negative correlation. And that's what these graphs down here show us. All right, so I want you guys to kind of sketch a linear line that goes through these points. And if you can use a straight edge, that's going to be the best option. But notice with these two negative sloped graphs, you have on the left side here, these points are very close to the line versus these points are a little bit more spread out, but they're still following the same pattern of that negative slope. And so with this one, because they're closer together, you're going to call it a strong negative correlation. And because these ones are further away, it's a weak negative correlation. But as soon as you have a positive relationship where the x value is increasing and the y value is increasing as well, then, oops, that's not a line through the center. Try to get that line straight through the center of your points. So as soon as it flips around and you have a positive slope, similar idea, when the points are closer together like this, then you have a strong positive. When they're a little bit more spread out, then you have a weak positive. Now, looking at the graph, you can verify just by kind of guessing about the spread of the points, but there's actually a number that is going to tell us this information as well, and that's called your R value. So we will be finding that with our calculator later on. Now, when we are looking at examples, we're going to be able to find these lines, but we also want to know kind of a little bit about what the scatter plot looks like. And so with this example here, we're going to be making a scatter plot. It says the table lists average monthly temperatures and electricity costs for a Texas home in 2008. The table displays values rounded to the nearest whole number. This is just easy for us to graph. We're going to be making a scatter plot, and we want to describe the correlation that we see. So let's go ahead and take this information. What's going to be our x value? What's going to be our y value? Well, which one depends on what? If you're looking at the average temperature of the month and then the electricity bill for that month, if you know anything about electricity, like your electricity bill, like it's going to be increased when you have your air conditioner on longer. And when you have hot temperatures, you tend to put air conditioning on more. When it's cooler temperatures, you might be opening the windows. All right, so our average temperature will affect whether we're turning on our air conditioner or not. So average temperature will be X, and then electricity will be Y. These are the same tables. It's just split up into two to save space. So that's still X, this is still Y. And so when we make our scatter plot, we want to put on our X values, we're going to put the average temperature down on the X axis. And then on our Y axis, we want to put the bill, and it's in dollars. If you can write it sideways, you can do that. But with my tablet, it's hard to write sideways. So I'm just going to write it up here. And our bill is going to be on our Y axis. All right, so we're going to be plotting these points, and we got to figure out like a good scale for our scatter plot. And so I'm going to find the smallest number here. Let's see, 58 looks like, yep, 58 here again. So 58 is my smallest number on average temperature. And then what's my biggest value? I see an 85, don't see anything higher. So 85 is the highest here. So basically I want to go 50 to 85. So let's kind of go to 90. So maybe going by tens would be good. So 10, 20, 30, 40, 50, 60, 70, 80, 90. And then for the electricity bill, let's do the same thing. Let's see, I see 150 and 139 is smaller. Oh, 110 right here is the smallest number here. And then what is our biggest number? I see 255. That looks like our biggest. So since we gotta get up to 255, maybe going by like 50s would be good. So we'll do like 50, 100, 150, 200, and 250. And then 255 will just be slightly above that. All right, so as we plot it, we want to take our X value and our Y value. So I'm going to pretend that this is an ordered pair here. You could even put parentheses and like a comma here if that you want to do that. So our first order pair is 61, 150. So I'm going to estimate where 61 is, and then go up to 150 and plot that. And then 58, 139, 58, 139 is probably about here or so. 67, 172. Going up a little bit right here. So what I would love for you guys to do is pause this video and start plotting your points. And I'm going to do the same so you don't have to watch me do all of the points. All right, so with your scatter plot, hopefully yours looks something like mine. Now, it's not a huge deal if you don't get it perfectly in the right spot. We're just estimating where our X values are and then estimating where our Y values are up. The most important thing is that your average temperature was your X value, so you're going right first, and then your electricity bill is your Y value, so you're going up first. So if your points look drastically different than mine, just make sure that you're plotting the X value first and then the Y value. But if it's slightly different, like this point right here is slightly over and maybe yours is right here, that's totally fine. It's just an estimation. It just allows us to be able to see what our correlation might be. Now, if we kind of sketch this regression line through, and maybe I should even make that a little bit steeper as well. And so try to get through the center of all of your points. Notice that's not going to be perfect, but try to have a straight line. Now, what type of correlation is this? Well, it's definitely not negative because you have a positive slope, you're going uphill. And then is it a strong positive or is it a weak positive? Now, I would say besides this point right here, all of the other points are very close to your line. So because the majority of your points are super close to your line, then that's going to be a strong positive. By the way, that is an R, not two O's, a strong positive. Now, with our next problem that we do, I will show you on your calculator even how to verify that it is a strong positive. So make sure that you have your calculator out right now, and we are going to be looking at some steps and be using the same data that we just used to make our scatter plot. So with this, the trend line that gives the most accurate model of related data is the line of best fit. So I've been kind of using the word regression line. Regression line and line of best fit are interchangeable. So I even want you guys to underline line of best fit, and I want you in parentheses to put regression line. I tend to use regression line more just because your calculator calls it linear regression, and it just kind of helps to keep vocab the same. But line of best fit means the exact same thing. Now, there are kind of different steps that you can take. I tried to simplify down our steps more on our calculator. So these are the simplified version of our steps. So let me just make sure we can get our data shown here so I can have the steps and the data being visible as we're working. All right, so first things first, we have to type in this data into our calculator. And so where we're going to do that is under the stat button. So it says type data into list 1, which are going to be your X values, and list 2 for your Y values. And so the stat button next to your arrows, hit stat, and then you're going to be hitting edit. You can either hit the number 1 or you can hit enter. Now, if you are not following along with your calculator, this is going to hurt you if you just watch my video. I really want you guys to have your calculator with you, doing the same steps, typing it in, because if you have an issue with your calculator, that's going to show here. And then you can see exactly what your calculator screen should be looking like because you'll be following along with mine. So make sure that you're following these steps too. So hit stat, and then you're going to hit enter on edit, and it's going to bring you to these lists. Now, I have a whole bunch of lists here because I have used my calculator already. But if you have numbers, you can clear this off and just hit clear and enter. And make sure that you are highlighted at list 6 or whatever list you're clearing, and hit clear and enter. Now make sure you don't hit delete because that will delete your list, and then you will no longer have a list 4. It will just go list 2, list 3, list 5. So if you ever delete your list, just let me know. So just make sure you're always hitting clear. If you end up hitting delete, I can fix it. But notice that you guys have 6 lists here. You can choose whatever list you want to use, but just for sake of simplicity, let's use list 1 and list 2. So now that our lists are cleared, what you're going to do is step 2. It says calculate the regression line. And we're going to do that by, we got to type in the data first before we calculate. So with your data, you are going to take these values and type them in here. So I'm going to start typing 61 and enter. Then I'm going to hit 58 and enter, and you're going to keep on going, doing all of these numbers. So 75, 79. Now, this is the most important step that seems simple and like you won't be able to mess it up. However, this is where the majority of our mistakes happen, and it's just because people type in something wrong. So notice I just accidentally typed in 84 instead of 81. And so just make sure that you're being careful typing in the right numbers. 81, 76, 65, 58. Okay, then when you want to type into list 2, you're going to go over and your right arrow will bring you right to the top of list 2, and you're going to type in those numbers, your Y value numbers. So 150, 139. Make sure you get the entire column of your Y values. 205, 170, 234. Now, one mistake would be is some people think like, oh, these are 2 different lists, so I need 4 lists total. No, X is your Y values, or X is your average temperature that goes into list 1. Y is your electricity bill. All of the electricity bill goes into the same column. So keep following 255 in your same list 2. And then 245, 210, 183, 132, and 110. Now, one thing to make sure of is you had the same exact numbers or amount of numbers in your list 1 as your list 2. So notice that this dashed line is in the same spot. If I had accidentally forgotten to type a number, then it would look like this. And then you know to be careful to search through to see what you missed. And then you can type it in. Now, say that you accidentally missed like this number here. Oops, I'll hit delete. Say that you actually missed a number and you don't want to have to like retype everything. You can highlight where you want it to go and then hit second insert and it will give you another row. So second insert can be a lifesaver so you don't have to retype everything. So I'll retype that 132 in there. And now we are ready to go on to step 2. So we've typed everything into our list 1, list 2. Now we're ready to calculate the regression line. So you're going to hit your stat button again. And then this time you're going to go over to calculate. So you got to hit the right arrow. And then it brings you a whole bunch of lists of things that you can calculate with your calculator. The one that we want is this linear regression on number 4. Notice that number 8 is the same thing, except for the BX here or the AX, like they just, whichever one comes first. So we're going to just work with 4, and I can explain that a little bit later, but either scroll down to 4, scroll down to 4 or hit the number 4, but I'm going to hit enter. And then we have to choose our lists. Now your calculator probably says list 1 and list 2, but mine I had changed previously, so I need to change it back to the default. So notice here that says select lists with the TI-84. If you have a different calculator, you might have a different screen, but the TI-84 allows you to set up what list you want to use. So if your list does not say list 1, I want you to hit second and then 1. Notice that the blue words right here say L1. This one says L2. So the next one, I'm going to hit second 2, and that's going to give me list 2. Now, frequency list and store regression equation can stay blank. You do not need those. And you're going to scroll down all the way and hit calculate. Now, your screen probably looks a little bit different than mine because I have the A and B values and the R squared and R. You probably just have A and B, and that's totally fine. You just don't have the setting yet to show you the R values. We will do that in class. And if you missed it in class, just make sure you talk to me and I will get you set up with your R and R squared values. So now that we have scrolled down, we highlighted, calculated, and pressed enter, all we have to do is take these A and B values and substitute them in to our equation. And notice that they give you the equation right there. So it's pretty simple. All you have to do is say, okay, my Y value will always stay Y equals my A value is 4.15. So just make sure that you round correctly and then include that X here. So 4.15X and then minus 117.68. I always like to round to the nearest hundredth or thousandth just for accuracy. And then I'm also going to write down this R value here. R equals 0.91. We will talk a little bit more about the R value in just a little bit, but let's go ahead and answer the rest of this question. And I kind of realized we didn't really read the question. So It says, earlier we found that the correlation for average temperature and the cost of your electricity bill is a strong positive. Now find the regression line for this data. How much do you expect to pay if the average temperature is 70 degrees? Now, we have found our regression line. That's going to help us. That's the line that goes straight through your data. Now, that line is going to help us make the prediction for 70 degrees. Because your average temperature was represented by X, then we're just saying, I want X to equal 70, and I want to know what my electricity bill, my Y value is going to cost. So all you have to do is plug that in and say 4.15 times 70, because that's for your temperature, minus 117.68. And let's find out what that is. So on this screen, you can either hit second quit, or you can just start typing in and it will clear that off. So 4.15 times 70 minus 117.68, press enter. We would expect to pay $172.82 if our average temperature was 70 degrees. All right, so that would be your prediction. So you're just taking a new X value and you're plugging it into your equation. Now, how accurate is that really? Like, do we know if that's going to be like how much I'm going to pay exactly? Are we going to be off by like $10, $100? Like, how far off are we going to be? Well, this R value of 0.91 kind of tells you how close you are to what it actually will be. And so if you go down to where it says correlation coefficient R, that indicates the strength of the correlation. And so the closer R is to 1, the more closely the data resembles a line with a positive slope, and the more accurate the model is likely to be. So R is always between -1 and +1. So if R is close to +1, that means that it is going to be a positive correlation. That's very strong. If it is -1, then that means that you're going to have a negative correlation that is also very strong. But if it's in the middle, if it's like 0.4, then it's a more of a weak positive, or if it's -0.6, that's going to be a weaker negative line. And so the fact that we have R equaling 0.91 means that we have a strong, and that is really strong for 0.91, we have a strong positive relationship. So we know that our predictions are going to be very accurate to what is really there. All right, so with your guys' math problems from the book, your R values are going to be stronger, just because you guys are learning this information. Your book wants you to make sure that you're getting accurate information. But when you go out into the real world, sometimes your R value is not that high. And sometimes you kind of have to accept that 0.6 might be the best R value that you can have. You might not have a super strong relationship. And so if you take stats, then you're going to learn more about your correlation coefficient and you're going to have messier data. But I don't know, I think that's kind of interesting. All right, let's go ahead and go to our last example here. So another problem where we are finding the regression line, and we want to just make sure that we're understanding our calculator and getting that practice in using our calculator. So again, make sure you're typing in the buttons, the same thing that I'm doing. And let's go ahead and read this. It says, you researched the average cost of whole milk for several recent years to look for trends. The table shows your data. Now, notice how the years are in years, where before we didn't have the years, we had like temperature. So one thing that you do with years, you always want to do years since some date. In the real world, you get to pick your own, but just for the sake of having an answer key and all of us making sure that we can do the problem correctly, I will pick them. And like on a test, it will be written on your paper. If it's on your homework assignment, if it's in your book, you can use the year that they give you in the book. But if not, like I will give it to you so that you're aware. So we're going to do the years since 1997. And so if we look at this, 1998 is 1 year after. So instead of typing 1998 into your calculator, you're going to type in 1. And then from 2000, that's going to be 3 years after 1997. So instead of writing 2000, I'm going to put 3. And then 2 years later, that's 2002. So then I'm going to add 2 more years. We got 5. I'm going to add 2 more years. So now we got 7, 2 more years. We got 9, 2 more years. Now we have 11. So 2008 is 11 years after 1997. So we're going to use these X values instead of the years, just because it gives us a little bit nicer of an equation and we don't have to deal with such big numbers. And then the average cost for 1 gallon of milk, we can leave that as is. And so let's go ahead and plug these numbers into our calculator. So that first step was to hit stat and edit. And then you're going to clear off that list. So highlight list 2 and hit clear and enter. Highlight list 1, hit clear and enter. And then now type these in. So I'm going to type in 1, 3, 5, 7, 9, and 11. Now, notice I did not type in 0 for 1997 because 1997 isn't in my table. I only want to include the ordered pairs that are in my table. And now I'm going to go over to here and type in the milk. So 2.65, the milk price, $2.89, $3. And if you have zeros afterwards, you don't have to type the 0 into your calculator. 3.01. So if I put like the 0 afterwards here, see how there's a 0, but as soon as I hit enter, it disappears. So just information there. So 3.2, I'm not going to type that 0 at the end. 3.77. All right, I'm noticing that my lists are the same size. That means I have the same amount of data in list 1 and list 2. And now I'm going to go calculate it out. So second, calculate. I'm going to scroll down to linear regression 4. Hit enter. I have list 1 and list 2 already saved from last time. So I'm going to scroll down and hit calculate. And there is your equation. So part A says, what is the equation for the line of best fit? How accurate is your line of best fit? Well, our equation is y equals, let's take these values, 0.09x and then plus b, so plus 2.53. And then how accurate is this line of best fit? R equals 0.92. This is very accurate. We have a strong positive relationship. Now it says, based on your linear model, how much would you expect to pay for a gallon of milk in 2020? Now, do I want to put 2020 in for my X? No, you do not, because you want to pay attention to the years since 1997. So 2020 minus 1997 will be the years since. So let's, if you want to use your calculator to do that, we can do that. So 2020 minus 1997, hit enter. That is 23 years after. All right, so because X stood for the years since 1997, then you're going to plug in 23. So 0.09 times 23 plus 2.53. And we're going to plug that into our calculator and let that simplify. So 0.09 times 23 plus 2.53. Hit enter on that, and it says 4.6. So what does that mean? Well, Y values represented average cost for 1 gallon. So we expect to pay, do I say 4.6? No, put it into context to say we expect to pay $4.60 per gallon of milk in 2020. All right, so because this is fairly accurate, I bet if you go to the grocery store, it might be similar, it might be close, but realize it's not going to be the exact value because it's a scatter plot. We're just making predictions. So have a great rest of your day and make sure you bring your calculator to class. See you later.